Okay, so right now what we're going to do for you is try to give you a very brief explanation of what exactly is going on when we turn a piece of metal into a temporary magnet. The first thing you need to know is what a permanent magnet looks like. So what you have here is the magnetic domain of a permanent magnet, and the magnetic domain is the region in which magnetic fields of atoms are grouped together and aligned. So you see here, here's the group of atoms, and they're all aligned, they're going in the same direction, and because of that you have your north pole of the magnet and then you have your south pole of the magnet. And again, that is your permanent magnet, so the ring magnets and the bar magnets that we gave you. Now you can take a piece of metal and you can use a permanent magnet to turn that piece of metal into a temporary magnet, but what you have to know is that a piece of metal doesn't look like this on the inside, so I'll show you what it looks like. So we have a piece of metal like a paper clip, which we're going to use in our experiment, and the atoms are all going to be facing different directions. And that's why it can't attract metal, it can't repel metal, it can't pick up anything. And because all those atoms are facing different ways, it's not going to have a north pole and it's not going to have a south pole. So again, it still technically has a magnetic domain, but since the atoms are all facing different directions, it's not going to work like a magnet until we try to magnetize it. So here we come in with our permanent magnet right here. We're going to take one side, which is going to be our north side of the magnet. We're going to stroke it vigorously like we did in our experiment, and like magic almost, what that's going to do is cause all the atoms to face the same way. Just like this. And that piece of metal, which again was a paper clip in our activity, is going to turn into a temporary magnet. And because it's a temporary magnet, it will have a north pole like a magnet does, and a south pole like a magnet does, and it will be able to work in the same way where it's repelling and attracting other temporary magnets. And so again, it looks like a permanent magnet for a matter of seconds actually, but then it loses its magnetism and it goes back to just being a piece of metal, or in this case, a paper clip. Seems a little complicated, but that's what's happening. And now what we're going to do is show you how to actually do it with our real paper clips and our real magnets.